Hi, this is Mr. Max. So I am continuing with the 3D problems. About 4 questions here. If you have the textbooks in Namibia, the y equals mx plus c to success for grade 10 and 11, you find this on page 259. I think that's the second book. But anyway, you will see that as well as the diagrams from I also drew some sub diagrams from the main one. It is mostly right angle triangles that will assist us in finding, you know, the solutions much easier than to try and do everything in the main diagram, so to speak, because it can be quite congested and so on. Anyway, so you have a rectangular base pyramid, as you can see. The vertex V is vertically above M, very important information, because you can see that it is a perpendicular with AC. And they ask us here that we need to find the length of CM. Now, if you were to use Pythagoras and you calculate the length of AC, then MC would be half of whatever AC is. And if you're aware of the Pythagorean triplets, that was like 3, 4, 5. All right, and if you were to say, for example, multiply this by 2, then you get 6, 8, 10. So that implies that the distance AC is 10. So my MC or CM that they are asking will be half of 10, which in this case is 5 centimeters. Now, if you're not aware of the Pythagorean triplets, then you can go ahead and you can use Pythagoras' theorem in order for you to find the value of AC. So you can still say AC squared is equal to 8 squared plus 6 squared. That gives you 64 plus 36, which is 100. And then you say AC is equal to the square root of 100, which gives you the 10. And that is the 10 that is here from that distance to there. Okay, good. Next question, they want us to find the height of VM. So now that I know that this distance here is 5 centimeters, now they want us to find the distance of VM. So again, I'm taking another triangle over there, and the triangle is VMC. So we know that MC from our previous work, or CM, or whatever you want to call it, is 5 centimeters. So we can find VM by simply using Pythagoras again. So we're looking for a short side, so we're going to say VM squared is equal to 13 squared minus 5 squared. VM squared is equal to, that's 169 minus 25. Then VM is equal to the square root of 144. That implies that VM is equal to 12 centimeters. So I'll just go ahead and I'll also write it here, 12 centimeters. Because here now, MC is 5 centimeters. Okay, so the third question they ask us the angle between CV and the base ABCD. So CV and the base. So this is this particular angle over here. So we'll have a right angle triangle that we have all the measurements. Okay, and that means we can use any of the trig ratios. That is what happens when you have all the 3 sides of a right angle triangle. You can use the tangent, you can use the sine. So if I was to use sine of theta, just going to indicate it by theta, it's going to be opposite theta, which is 12 divided by the hypotenuse. If someone was to use the cosine of theta, that will be whatever is adjacent to that, in this case 5 upon 13, so that's what the ratio is. If someone was to use the tangent of theta, tangent is opposite, which in this case is 12 upon 5, which is the adjacent. Remember, the tangent is the only one where you can have an improper fraction. Any one of these is going to give you the solution for our answer. And you can go ahead and you can check that on the calculator. I'm just going to write them down just for your consideration. Finding the inverse, even if I was to use the 10. So the sine would be 12 over 13. We'll see what that gives us. The cosine is 5 over 13. and the tangent is 12 over 13. 12 over 5 rather. And let's grab our calculator, and you will see if I was to use the sign, so inverse button of 12 upon 13, and I hit enter, you see I get 67 point, let's say 67.4 degrees. That is correct to one decimal place. Suppose I want to use, or I wanted to use the cosine, so the cosine would be the inverse cosine of 5 upon 13. Remember, the cosine and the sine, the angle, the ratio should always be proper, means numerator smaller than denominator. Can you see I'm getting the same answer, 67.4? And lastly, if you were to use the tangent ratio, you'll also get the same answer, so inverse tangent of 12 upon 5. This is the only ratio where you can have an improper fraction. 67.4 again, so any one of them will give you the required answer. Okay, let's go to the second question. This is a cube. The length is 10 centimeters, you can see. Then there are some midpoints given. M is the midpoint of BF, and N is the midpoint of AE. So that implies that this distance here must be 5, and that distance must be 5. Similarly, on the other side must be 5 and 5 as well. And they want us to find angle MEN. So let me just bring in a triangle over there to see what it means. So angle MEN. So the angle they are looking for, angle MEN, is this angle over here. And I've indicated by drawing the diagram on the other side. Then NM is going to be 10, and this is 5, so I'm going to go ahead and put my 5 there. And I can calculate that missing angle now. Because I've had two sides, I can calculate the third side using my ratio. Well, the ratio I'm going to use will be the tangent ratio, and it's the tangent of 10 divided by 5 opposite over the adjacent. So I can go ahead, just want to have this answer. So that is going to be, the angle will therefore be the inverse tangent of 2, because 10 divided by 5 is 2. Right, so let us see what this particular angle is. So when looking for the angle, we are going to use the inverse tangent. Since I still have this information here, I'll just go ahead and clear it, and that gives me 63.4. So that is 63.4 to one decimal place. Good. So now they want angle EMN. All right, so let's just go ahead and quickly fill in what I have here. So that was 5 centimeters. So EMN, which is this angle here that I've indicated by alpha. Remember, this was my theta. And from what you know is that theta plus alpha should give you 90 degrees. Okay, because the angles of a right angle triangle add up to 180. So since this one is already 90, the other two definitely should add up to 90. So my alpha will be 90 minus my theta, which I calculated from before. So alpha will be 90 minus 63.4. Okay, and just punch that in on the calculator in order for me to find the missing value. I'll just say, okay, 90, take away the answer that is still programmed there, 26.6. That will be 26.6 degrees. So alpha is 26.6 degrees. Of course, angle EMN. Now, the third part C, they are asking for angle MEF. And the way I drew it here, if you go back to the angle MEF, so we knew what this was my alpha here. Then alternate angles, that is also going to be alpha over there. And that is why I took those two triangles, so to speak, and I put them on top of each other for you to see. So the solution here is quite clear that angle MEF is also 26.6 degrees to 1 decimal place. Right, part D, I had to bring the diagram back. They want us to find the angle between HB and the base. So basically, if I show you the second diagram, this is the angle here they are looking for. This is the particular angle they are looking for. So I've indicated with theta over there. But before I can calculate that angle, I need two sides. And that is where DB comes in. So I need to calculate dB. So that's the first thing that I'm doing. So how do I find dB? So I'm using triangle DAB, which is the one here under, as you can see. So 10, 10 here. So dB will be calculated using Pythagoras' theorem. So dB squared is equal to 10 squared plus 10 squared. Okay, that is going to be 200 if you add them together. So dB is going to be the square root of 200. And the square root of 200, well, that is nothing but 10 times the square root of 2. I'm leaving my answer in third form. Okay, you can go ahead and you can give your answer in, change it from third 14.1. Okay, I just want to leave it there. So I'm going to say this is then 10 root 2. I'm going to change it later because I'm still calculating something. So dB is 10 root 2. So I'm just going to go ahead and here I put my question mark. I'm going to replace that question mark now with 10 root 2. Now that I have these two sides, I can actually calculate this. Again, using the tangent. Tangent is the opposite over the adjacent. So go ahead and grab the calculator. You say, okay, this is the inverse tangent of 1 over root 2 or 10 over 10 root 2. Either way, you get the answer. Okay, you don't have to be too specific. So let's grab our calculator and say, okay, we are calculating the inverse tangent of 10 divided by 10 root 2. Okay, and then if you, oopsie, just go ahead and close that one and hit enter. You get 35.3, 35.3 to 1 decimal place. So 35.3. So my angles are given to 1 decimal place. All right, so that brings me to question number 3. Now I'll give you some time maybe for you to peruse through the question, get used to it, and then you attempt also to solve it. So what they're asking here, or they are giving you the information, they say that this is a right square pyramid, so the base is 10, 10, 10, 10, so on. AB is equal to BC, as you can see. EF is 15 centimeters, M is the midpoint. Now that is very important if that is the case. So if that's the midpoint, then if you were to drop a perpendicular, it makes 90 degrees there. That is why I took that triangle EMC and I drew it here. And what is it I know? Well, since they are saying it's the midpoint and the distance from B to C is 10, then the distance from C to M must be 5. So now for me to find EM, I took that triangle there, okay, and it's very easier then to work. So you know that this triangle over here, this is a triangle that I have over here. Okay, now since I have the triangle over there, I can definitely calculate what the value of EM is. And since I'm looking for a short side, so EM square is equal to 15 square minus 5 square, which is 225 minus 25. Okay, just go ahead and say, all right, that means that EM is equal to the square root of 200. Now, you can grab a calculator again, or if you know from my answer before, the answer in third form is 10 root 2, but I'll put it up there again. So if you take the square root of 200, you get 10 root 2. So this is 10 root 2. Now, since that is the question or the what we are looking for, so I'm going to change it from third form to normal decimal form. So it's 14.1. So this is 14.1. Of course, all these measurements here are given in centimeters. So that will be 14.1 centimeters. Right. Then they want the height of. Now we know what EM is. So EM, we just calculated 10 root 2. I'm just going to leave it in third form. So this is 10 root 2. Now they're looking for the height here of EN. Again, then to say EN squared equals to 10 root 2 squared minus 5 squared. All right. So let's just bring in our calculator and see what value do we get. So we're going to take, okay, good. That is 10 root 2, or you can use your answer there, 14.1. Squaring that, and then we minus 5 squared, which is 25. We get 175. So En would be the square root of 175. And let's go back and find what is the square root of our answer there. 5 root 7. So this is 5 root 7. Or you can go ahead and say En to three significant figures, change it from third to decimal, is 13.2. So that is like 13.2 centimeters. I'm going to pause so you just can have a look and see what I did there. Right, so let's go then to part C, and I brought down my diagram again. They want us to find angle EMN. Now I've indicated the triangle, as you can see there. So what do I know? I know that the distance from N to M is 5 because, you drop the perpendicular there. And that distance always 10, so that is 5. What do I know? I know that En from my answer before, En 13.2, or I just use the third form, which is 5 root 7. So I'm going to go ahead and write 5 root 7. I also know the value of EM because we calculated EM before. That was 10 root 2. So I'm going to bring 10 root 2 over there. So what is it that we are noticing? We have got three sides of a right angle triangle. We can use any of the ratios, okay? I can use the sine ratio, and I will use the sine ratio. The sine ratio is opposite, which is 5 root 7, over the hypotenuse 10 root 2. Well, you don't have to simplify that. You can just go ahead and punch that in on the calculator in order for you to find that angle. Of course, we can also use the cosine, and we can use the tangent ratio, because we have all three sides given. Okay, whichever one you use, you should be able to get the same answer. Make sure your calculator is in the right mode. I keep on saying this. I'm seeing people making a lot of mistakes. This goes over 10 root 2. So for you, those of you who wanted to simplify over 10 to half, there's absolutely nothing wrong doing that. Just remember, some work is unnecessary. So 69.3, if you have to look at that to one decimal place, so 69.3. Okay, let's make sure we've captured it correctly. So it's totally up to you which ratio you want to use. You still get the same answer. Like if you were following my video from the beginning, you will see that I have indicated to you a case where you have given three sides, and the moment you're given three sides, you can definitely calculate the other sides. Now, the problem also sometimes with using the this rounded answers is that your angle might slightly be out here. So I suggest that you work with these third forms, or if you work with rounded answers, that maybe you give more decimal places, up to 4 decimal places, so that your answer might not be out by a 0.01 degree or something like that. All right, so that brings me to the fourth and last question in this particular simple 3D shape. So you have a wedge here, and they are saying that PQRS, is perpendicular to ABRQ. So basically, it means this is 90 degrees, and so on and so on and so on. Okay, I've indicated with that. And they will ask me a bunch of questions. The information is BR is equal to 4 meters, AB is equal to QR, okay, which is 6 meters, and RS is equal to 2 meters, and so on. Now, first one, they want me to find BS. So I just took that triangle and I realized, oh, wait a minute, this is just nothing but the use of Pythagoras. Pythagoras is 2 squared plus 4 squared. Okay, so 2 squared is 4. 4 squared is 16. So I'm going to look for the square root of 20. So BS will be the square root of 20. And let's see what do we get on the calculator once we punch that in. We're going to take the square root of 2 squared plus 4 squared, which is 4 point, let's just have it as 4 point, let's go back to the calculator, 4.47, 4.47. Everything is in meters. All right, just to show you that I get the same answer if I was punching in the square root of 20. So if I punch in square root of 20, I get the same answer, that is 4.47. So 2 root 5 is also 2 root 5. That is the answer in insert form. I probably leave it like that, insert form, because I might use it for the next question if there is a need for that. So now they ask me to find AS. Now, if you look at AS, it's this blue one that I put over here. So what do I know? I took the triangle, this ABR. So ABR, the one at the bottom, and I've indicated the values. Okay, so the first thing is I'm going to find AR. Once I find AR, then I'm going to find AS, because if you look at that cleanly, what is it that I'm looking for? Actually, I am looking for this particular triangle here. So let's just suppose there's a triangle that you somehow slide into that wedge. So this is what I'm looking for in terms of A to S, but I cannot just calculate AS because I don't have, a third side. So again, this over here is 90 degrees also going this way. So what I need to do is I need to be able to calculate what AR is. That is why I took that triangle ABR. And once I know what AR is, then I'm going to find AS. Okay, so that's what I indicate over here. Right, so let's see. AR, using Pythagoras, AR will be the square root of 6 squared plus 4 squared. Né? All right, so I'm going to leave it in third form again so that my answers are not too far off. So 6 squared plus 4 squared. Sometimes you use different calculators, then you have to put brackets here. Okay, especially those calculators not so well programmed. So this is 2 root 13. So this is 2 root 13. Or if you want to work it in decimals, you can go ahead and change it from third to decimal. 7.211. 7.211. Let's see how many places there. So maybe another one. So what I meant is, if you were, because you're still going to use this distance and you don't want to work with third form, which is an accurate form, you can give your answer at least to 4 decimal places and still continue, because otherwise this is known as premature rounding and it might affect your answer slightly. So I know AR is 2 root 13. So I'm going to go ahead and put AR 2 root 13. Now they want me to find AS. So now the triangle that you're seeing, this triangle here, is the one in yellow that I've indicated on my diagram. So I'm just going to show you, by just going back there. So this one is the one in yellow that I have highlighted there before. So that is the triangle that you're seeing over there. Okay, ARS. Okay, can you see that? Now I can find AS. Again, just use Pythagoras. It's quite straightforward. So AS squared is equal to 2 root 13 all squared plus 2 squared. then AS will be whatever that answer is, I'm going to take the square root of that answer. So let's go and hit on a calculator. So I'm going to say 2 root 13, okay, close that, square plus 2 squared, so that gives me 56. So I have got 56 here. Oh my goodness, that's 56. Doesn't look so nice. So let's just bring it back and write it nicely. And then I can use my calculator, say, well, what is the root square root of 56? Is 2 root 14 in third form. So what is it now to three significant figures? Change from third to decimal, 7.48. 7.48 meters. Okay, make sure that you specify, you give your answer according to the degree that they are looking at in the particular question. Right, so 7.48 meters. Right, let's go back and find, they are saying find angle SBR. So just go back to the main diagram. SBR. So again, it's that triangle that I have over here. I have the 2, I have the 4. I don't have to worry about SB. Okay. I can just use, they're saying SBR. So let me just bring in theta. Let's just grab a different color. So this is the angle that I'm looking for. The one in the middle, SBR. So I'm going to use the tangent ratio. The tangent is opposite, in this case 2 over the adjacent, which is 4. That's like a half. So in order for you to find the angle, you take the inverse of 2 over 4. And we're going to grab our calculator and see what we get. Okay, so we say shift tangent of 2 over 4 or a half, whichever way you want to slice it. 26.6, right? It's 26.6 degrees, of course, to one decimal place. Then part D, now let's just bring in what AR is, because we did calculate AR before. Can you see that AR here is 2 root 13, okay? Remember, AR is the one under here where I used the 4 and the 6. So AR is 2 root 13. So I'm going to take that 2 root 13 and I'll write it here. So I have 2 root 13 because they want me to find angle ASR. So I'm going to say that is the angle over there. Again, that implies I must use the tangent of opposite, which is 2 root 13 over 2. Okay, so this is just going to be the same as root 13. So the inverse tangent of that answer, let's grab our calculator and we can go back and just clean it up and say, okay, root 13 like so. 74.5 degrees, 74.5 degrees. So that's 74.5 degrees. Okay, that is the end of this segment.